Article 760 of the National Electrical Code addresses the installation of fire alarm systems. Specifically, Section 760.29 Code states that conductors shall be installed in accordance with the requirements of Chapter 3. Chapter 3 of the National Electrical Code covers wiring methods and materials. Section 300.14 of the National Electrical Code states that conductors shall be installed in a raceway, an approved cable, or other approved means. Based on these code requirements, it is necessary to run the wires from the transformer into an electrical box before connecting them to the back of the alarm input terminals. This will ensure that the wires are properly protected and will not be exposed to damage. The reasons for needing an electrical box stem from safety and code compliance. Firstly, electrical boxes provide physical protection for wiring connections. This prevents damage from external forces, such as impacts or abrasions, which could lead to short circuit or other electrical hazards. Secondly, electrical boxes contain and protect the wire splices and terminations. These connections are often points of potential failure, and the box helps to prevent accidental contact with other materials or objects, reducing the risk of fire or electrical shock. Thirdly, the National Electrical Code mandates the use of electrical boxes in many wiring scenarios to ensure safety and standardization. This requirement helps to maintain a consistent level of protection and reduces the likelihood of improper or unsafe installations. Fourthly, electrical boxes help to manage and organize wiring, making it easier to inspect, maintain, and modify the system in the future. This organization also reduces the risk of accidental disconnection or damage during maintenance activities. Fifthly, metal electrical boxes can provide grounding and bonding, further enhancing safety by providing a path for fault currents to return to the source, tripping circuit breakers and preventing electrical shock hazards. When running wires for a 24 volts alternating current alarm system, it is essential to understand and adhere to the relevant sections of the National Electrical Code, or NEC. These codes provide specific guidelines on how to safely and correctly install electrical wiring. Chapter 3 of the National Electrical Code covers wiring methods and materials. This chapter contains requirements for the types of cables, conductors, and raceways that are permitted for different applications. It also specifies how these materials should be installed to ensure safety and prevent damage. Article 760 of the National Electrical Code focuses specifically on fire alarm systems. This article provides detailed requirements for the wiring, installation, and protection of fire alarm circuits. It covers aspects such as power sources, circuit integrity, and the separation of fire alarm wiring from other electrical systems. Section 300.14 of the National Electrical Code addresses the length of conductors at outlets and junction boxes. This section requires that a minimum length of free conductor be left at each outlet, junction, and switch point for making connections or repairs. This ensures that there is enough wire to safely work with without stressing the connections. Section 760.29 Code of the National Electrical Code states that fire alarm conductors must be installed in accordance with Chapter 3. This means that all the requirements for wiring methods and materials outlined in Chapter 3 must be followed when installing fire alarm wiring. Raceways and cables. Firstly, the National Electrical Code specifies approved raceways such as electrical metallic tubing or EMT, rigid metal conduit or RMC, and flexible metal conduit or FMC, and cables like non-metallic sheet cable type NMB, metal-clad cable type MC, and fire-resistant cable for fire alarm systems. Secondly, conductors must be sized appropriately for the current they will carry, and the installation must be rated for the voltage and temperature of the application. The National Electrical Code provides tables and guidelines for determining the correct conductor size and installation type. Thirdly, wiring connections must be made inside approved electrical boxes or enclosures. These boxes provide physical protection for the connections and help to prevent accidental contact with live wires. Fourthly, fire alarm wiring must be separated from other electrical systems to prevent interference and ensure the integrity of the fire alarm circuit. The National Electrical Code specifies the minimum separation distances required. Fifthly, Fire alarm systems often require special wiring methods to ensure circuit integrity in the event of a fire. This may include the use of fire-resistant cables or the installation of circuits in a manner that prevents a single point of failure from disabling the entire system. The OJ, or authority having jurisdiction, plays a crucial role in interpreting and enforcing the National Electrical Code and local electrical codes. Here are several key aspects of their involvement. Firstly, the AHA is responsible for reviewing and approving electrical plans and permits. This ensures that the proposed electrical work complies with all applicable codes and regulations before any work begins. Secondly, the AHA conducts inspections of electrical installations to verify that the work has been performed in accordance with the approved plans and the National Electrical Code. These inspections help to identify and correct any deficiencies or safety hazards. Thirdly, the AHA has the authority to interpret the National Electrical Code and other electrical codes. This is important because the codes can sometimes be complex or ambiguous, and the AHA can provide clarification and guidance on how the codes apply to specific situations. Fourthly, the AHA enforces the National Electrical Code and local electrical codes. This may involve issuing notices of violation, requiring corrective action, or even imposing penalties for non-compliance. Fifthly, the AHA may have the authority to grant variances or waivers from certain code requirements in special circumstances. However, these variances are typically only granted when it can be demonstrated that the proposed alternative provides an equivalent level of safety. Grounding and bonding are critical aspects of electrical safety, ensuring that electrical systems are properly connected to the earth and that all metal parts are at the same electrical potential. Firstly, grounding involves connecting the electrical system to the earth through a grounding electrode, such as a ground rod or a metal water pipe. This provides a low impedance path for fault currents to flow back to the source, tripping circuit breakers and preventing electrical shock hazards. Secondly, bonding involves connecting all metal parts of the electrical system together to ensure that they are at the same electrical potential. This includes metal conduits, enclosures, and equipment housings. Bonding prevents voltage differences from developing between these parts, which could create a shock hazard. Thirdly, the National Electrical Code specifies detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods for making grounding connections, and the location of grounding electrodes. Fourthly, proper grounding and bonding are essential for protecting people and equipment from electrical shock hazards. They also help to reduce the risk of fire and damaged electrical equipment. Fifthly, grounding and bonding should be inspected and tested regularly to ensure that they are functioning properly. This is typically done by a qualified electrician using specialized testing equipment. When installing a 24 volts alternating current alarm system, consider the transformer requirements. Firstly, the transformer must be properly sized for the load it will be supplying. This means that the transformer's volt-amp or VA rating must be sufficient to handle the total power requirements of the alarm system. Secondly, the transformer must be installed in a suitable enclosure to protect it from physical damage and environmental conditions. The enclosure should be rated for the environment in which it is installed, such as indoor or outdoor use. Thirdly, the transformer must be properly grounded and bonded to ensure electrical safety. This is typically done by connecting the transformer's grounding terminal to the building's grounding system. Fourthly, the transformer must be installed in a location that is accessible for maintenance and inspection. It should not be installed in a concealed or difficult to reach location. Fifthly, the wiring connections to the transformer must be made in accordance with the National Electrical Code and all local electrical codes. This includes using the correct wire size, insulation type, and connectors. If the wires are flush mounted in the wall, consider the fire rating requirements. Firstly, when running wires inside walls, it is important to use cables that are rated for use in walls. Type NMB cable, also known as Romex, is commonly used for this purpose. Secondly, if the wall is fire rated, such as in a commercial building, it may be necessary to use fire-resistant cables or to protect the cables with a fire-resistant material. This helps to prevent the spread of fire in the event of an electrical fault. Thirdly, the National Electrical Code specifies requirements for the installation of cables in fire-rated walls. These requirements are designed to maintain the integrity of the fire rating and to prevent the spread of fire. Fourthly, when installing cables in walls, it is important to avoid damaging the insulation or the cable itself. This can be done by using proper installation techniques and by protecting the cables from sharp edges or other potential hazards. Fifthly, all wiring connections must be made inside approved electrical boxes or enclosures. These boxes provide physical protection for the connections and help to prevent accidental contact with live wires. Always refer to your local code or AHJ for the most accurate information, because local codes can vary and may have additional requirements beyond the National Electrical Code. The ORG, or authority having jurisdiction, is the local authority responsible for interpreting and enforcing electrical codes. They can provide guidance on how the codes apply to specific situations and can answer any questions you may have about electrical installations. Always consult them to ensure compliance and safety.